Okay, let's go ahead here, and this is video number 27, and I'm doing those two new challenging problems, so-called, and now I'm going to explain them in detail, and I'm going to hold off a little longer on the simplification of radicals, and just sort of do them, and then begin to assign you simple problems so you get more comfortable with them. So let's see what happens here. I'll assign you two more today, so maybe some of you will be able to come up with the answers on your own. Let's see what happens here. All right, so here, nothing's new. There's number 6. The diameter is 6, big deal. That means the radius is 3. The slant, not the height, is 9. And that's where things get a little different here, right? Let's take a look at that. We proceed as we did with the problems I did this morning earlier. And I write my 3 here, of course. I drop a perpendicular bisector. There's my right triangle. And now the hypotenuse is 9. Oh. So I have a triangle. If I extract it in my head, there's the right angle. And I have a base or a leg of 3, and the hypotenuse is 9. So when I write a squared plus b squared equals c squared, then 9 squared goes here right away, and you should see that. That's been explained to you. Okay? And we'll call the guy we don't know x squared, because we don't know the leg over here, plus 3 squared. And now we have a problem that ties in with what we're doing, but in a more sophisticated way that you should be aware of as you move along in your mathematical career. So let's see. We need x squared, which is this leg here, the height, the perpendicular bisector. Otherwise, we can't calculate the volume, is what we need here, right? Same problem as before. I just changed the number. Instead of 10, I wrote 9. Instead of 13, I wrote 9. No more Pythagorean triples. So a squared, x squared equals 9 squared. I take the opposite of 3 squared, which is negative 3 squared. What you do on one side, you do on the other. And then we have x squared, let me make sure this is going on, yeah, equals 81 minus 9, which equals 72. Oh my God, x squared equals 72. And now we're running into some new math. I'll do it over here. So that means that when I put the hat on both of these guys, I'll do it like that since it's a video. We have x equals radical 72. Oh my God, that's the height. Radical 72. Take it or leave it. That's what's going on in the math. The height is radical 72. So I'll just put a little arrow there and write radical 72h equals that. But in math, if the numbers are right, we can simplify these radicals. And what we do is we look for a perfect square, the biggest one we can find, that fits into 72. Oh my God, if I think about it, it's equivalent to say that 72 equals 36 times 2. But why does 36 work? 36 is what? Another perfect square. So x equals radical 36 times radical 2. We'll explain that in a little more detail as we move along, but the radical 36, of course, being a perfect square, is x equals 6 radical 2. Isn't that nicer? Instead of writing this monster number that requires a calculator and all sorts of stuff, instead of radical 72, I can write 6 radical 72. All right, I'll step over here, try not to make a big mess over here, and now I can figure out the volume. Let's see what's going on here. V equals 1/3 pi times, 6 radical 2. That's the height. Oh, let's keep doing the same thing. 3 times 3, which is 3 squared, and then times 6 radical 2, which is the height. So I just want to slow up here. There's h. There's r squared. 8th graders need to understand that. That's you're going into high school next year. You have to understand that kind of stuff. So now we work on, it's in terms of pi. One of the 3's cancel. And now we get this answer. Maybe it's a little surprising to some of you, but what is the volume? The volume is pi times 3 times 6 times radical 2. Oh my God, it's 18 radical 2 pi. Oh, well that's kind of neat. We can do math this way. All right, what's radical 2? What's radical 2? I'll grab my calculator. We'll talk more about that, and we can work. We're rounding it like we talked about. We'll certainly go back to that because I told you we're going to do calculator work here. But to the mathematician, this is a perfect answer. This is precise as far as they're concerned. This is absolutely precise. Okay, let's erase everything here. Hopefully I made the point clear. And now you're expecting the same thing to happen in the next problem that I assigned to you. And number 7, so let's get it out. Oh, it's a little nicer to do these cylinders. So there's a nice big fat juicy cylinder. There's number 7. The area is 20 pi. That's the data again. And the height, just to make the math easier so we can do it by hand, is 5. And we need to know what the volume is. So there we go again, where we're working on a problem like this. Well, here we go again. If A equals pi r squared, and at the same time A equals 20 pi, because the data was given there, then pi r squared must equal 20 pi. That means, as we've done repeatedly, r squared equals 20, and that means r equals radical 20. Oh, okay. So there's r equals radical 20. Boy, that's a big number. What's radical 20 mean? Oh, I can simplify radical 20 too and make my calculations come out really neat here. So let's see what happens. Oops, a lot of glare. We go through here. What does radical 20 equal? Well, let's see. Radical 20. What's the biggest perfect square I can come up with that multiplies, it's a multiple, that 20 is a multiple of? How about 4? Yeah. 4 times 5 equals 20. These guys are equivalent. It's the same number. I just wrote them differently. Oh, well that means that radical 4 times radical 5 equals 20. Oh, but radical 4 is a perfect square. There, it's much nicer. The radius really, to make it easier for us to do calculations, equals 2 radical 5. Oh, all right. We can do math like this. Now I can find the volume. I turn my attention over here, moving across the board over here, and V equals pi, 2 radical pi, that's the radius, squared. Oh my God, that's the first time we're squaring one of these little buggers, times the height, which is 5. So let's see what happens here when we square this little guy. Let's see, 2 radical 5. Times 2 radical 5, right? That's the radius. Didn't we agree to that? Well, let's see. 2 times 2 is 4. 5 times 5 is what? Radical 5 times radical 5, of course, is 5, as we've said so many times. So the volume is what? Pi times 20 times 5. And we come up with a simple answer here. 100 pi is the volume of this particular cubic units, of course, is the answer to this particular question. Having given the data, we're not afraid of using these radicals. We're not afraid of doing this kind of stuff. We're going after these things. And not to get confused with my video things, I'm going to give you some exercises. I'll put them on the whiteboard and I'll simplify various type of things that you can simplify, and then I'll talk about what you can't simplify and what. And then we can add these guys together, divide them, subtract them, do anything we want. But how nicely that worked out the way it did. as you follow the steps going on here with the math. Okay, I'm going to leave it at that, and I'm going to work now on assigning you new problems, 2 of these new guys, to see if it's okay.